Hi everyone, let's cram for chem and we'll study as much chemistry as we can in a short amount of time. In this video, we'll talk about periodic trends. As the name implies, we'll be focusing on the periodic table. Specifically, we'll be looking at the patterns on the periodic table. The theme for this topic will be Coulomb's law. It looks like this. Here's what all the variables stand for. F is the force of attraction or repulsion between particles. For periodic trends, we'll focus on the attraction between protons and electrons. K is a constant. Q means charges. We'll look at the positive charge of the nucleus, which is called the nuclear charge, and how that interacts with the negative charge of the electrons. R stands for distance, so distance between the nucleus and electrons. This might seem like a complicated formula, but to understand periodic trends, you just have to know when there's strong attraction between the nucleus and the electrons, and when there's weak attraction. You'll know whether an attraction is strong or weak if you just focus on charges and distance. Here's how to get strong attraction between the nucleus and the electrons around it. The first option is having a large nuclear charge. Between these two atoms, fluorine has more protons, which means it has higher nuclear charge, so fluorine will attract its electrons more than oxygen does. The second option is having small distance between the nucleus and electrons. Here's helium and neon. If we look at the outermost electrons, helium's outermost electrons are a lot closer to the nucleus because it doesn't have an additional inner shell. As a result, helium's outermost electrons will have stronger attraction to the nucleus. The first periodic trend we'll talk about is atomic radius, which is the size of an atom. Atomic radius increases towards the bottom left corner of the periodic table. The smallest atom on the periodic table is helium, and the largest is francium. Why is that? Let's compare within the same row. The atoms on the left-hand side of the periodic table have less protons compared to the atoms on the right. Less protons means weaker attraction to the nucleus, so we get larger atoms on the left because the electrons are more spread out. On the right-hand side, the atoms have more protons, so there's a stronger attraction that pulls the electrons toward the center and shrinks the whole atom. When you go down a group, there are more electron shells, so atoms get bigger. When we put those two together, we get atoms that are bigger when you go toward the left and down the periodic table. Ions will have different atomic radii compared to the original atoms. Let's define ions first. The first type of ion is a cation. Cations are formed when atoms lose electrons and become positive. I like to remember that this T in cation looks like a positive sign, so cations are positive. Most cations lose their valence shell, like in this picture here. This is lithium. If it loses its one valence electron, its entire valence shell will be gone. As a result, cations are always smaller than the original element. The second type of ion is an anion. Anions are formed when atoms gain electrons and become negative. Here's fluorine. If fluorine gets an extra electron, all of its valence electrons will repel each other more than before because like charges repel. This will cause the electrons to spread out. As a result, anions are always bigger than the original atom. The second periodic trend is ionization energy. Ionization energy is how much energy it takes to remove an electron from an atom. This is how ionization energy increases on the periodic table. Helium has the highest ionization energy, and francium has the lowest. Here's why. In the same row, atoms on the right have more protons, so they attract their electrons more. It'll be harder to remove their electrons, and they'll have higher ionization energy. In the same group, when you go up a group, there are less electron shells, so the valence electrons are closer to the nucleus. They'll have stronger attraction to the nucleus, so they'll have higher ionization energy. Another periodic trend is electron affinity, which is how much an atom attracts an extra electron. Here's how electron affinity increases across the periodic table. Fluorine has the highest electron affinity, and francium has the lowest. Something important to remember is that noble gases do not have electron affinity. They're happy with their full valence shells, so they don't attract extra electrons. Let's look at the charges first again. Going across a row, the atoms on the right have more protons, or higher nuclear charge, so they attract electrons more. Atoms on the right have higher electron affinity. Going up a group, there are less electron shells, so electrons are closer to the nucleus and experience stronger attraction. It'll be easier for smaller elements to attract outside electrons. The last trend is electronegativity. This trend is almost the same as electron affinity, there's just a slight difference in definition. Electronegativity is for bonded atoms, and it looks at how much an atom attracts shared electrons in a chemical bond. Just like electron affinity, noble gases don't participate because they don't want to disturb their full valence shells, so they usually don't form bonds. Among the rest of the elements, this is how electronegativity increases. Fluorine has the highest electronegativity and francium has the lowest. Electronegativity increases across a row because atoms on the right have more protons, so they attract electrons more. Electronegativity increases up a group because the atoms near the top have less electron shells, so electrons are closer to the nucleus and experience stronger attraction. I hope this video made periodic trends short and simple. Thank you so much for watching, and I'll see you in the next one.